Breakdown is a concept of a tool which helps people with dyscalculia to develop a better understanding of numbers through practice the segmentation of amount. The name breakdown is chosen as a neutral description of what the program does. It shouldn't give a learner the message that he has to use the program cause of his problems. Dyscalculia is defined as a weakness in handling with basic mathematical operations like addition, subtraction, multiplication and division in independence to the level of intelligence. As technical device, it's planned to use the Sifteo cube. These are little cubic displays which are able to communicate to each other. Furthermore, you can install special software to them and implement new programs with a special programming language. The working with the Sifteo cubes contains one problem. The Sifteo cubes are too small, so that primary school children are unable to read operating instructions on the display. So, the Sifteo cubes have to communicate with a bigger display like a tablet, a tabletop, a notebook or a PC, which shows learners these instructions. This is called the proxy interface. The problems people with dyscalculia have are often similar. An inability to find connections between numbers, the variant understanding of amount, the ordinal confusion, cardinal invariance, and counting instead of calculating. People with dyscalculia have problems to establish connections between numbers. For instance, the knowledge that 1 is smaller than 2 and 6 is bigger than 5, or the result of 2 plus 5 is the same as 5 plus 2. Furthermore, they have problems with the classification. So, here we see some apples and bananas. We have to categorize them so that we can count them. Here we see 4 lady beetles. People with dyscalculia count them, but they see the numbers as names. If we change the place from the last lady beetle from the end to the beginning, they think that it's still the number 5, also it's now the number 1. It doesn't matter how we represent the 4 lady beetles, if we do it like in the first or in the second line. People with dyscalculia would say that in the second line are more lady beetles than in the first line. People with dyscalculia don't calculate if they have to solve a mathematical task. They count till they have the result. This problem isn't avoidable by working with small numbers, but these people came into trouble if they have to calculate with bigger numbers like 100 and 1000. The following short video sequence from the TV magazine Xenius shows this strategy when a young lady with dyscalculia should calculate a simple mathematical task.
Nadja, wie würden Sie die Aufgabe 15 minus 7 rechnen?
Ja, 14, 13, 12, 11, 10, 9, 8 kommt da raus.
Ja. Nadja, wenn Sie die...
To avoid this strategy, the numbers are presented in the way of the Zwanzigerfeld by Wittmann-Müller. So, the red circles are the numbers 1 to 10, the blue circles are the numbers 10 to 20. The students are trained to get amounts simultaneous in this way. The program has 3 modes a user can work with. The tutorial mode introduces the user into the functions of the program. The course mode is a systematical course with fixed tasks, and the experimental mode is a free working mode without a course structure. Here you see like the proxy interface looks like. I decided to design it like a ticket machine, because there you give something in and take something out into real life, and you segment money. At the big display in the middle, you see the amount you should segment. The Sifteo cubes shows on how many Sifteo cubes you should segment the amount. You can take something out by holding a Sifteo cube to the green button, and you can give something in by holding the Sifteo cube to the red button. The field on the right shows the number of possibilities for segmentation and the tasks which are solved in the right way. Here a user has to segment the amount 4 to 2 Sifteo cubes. So he holds the first CiFTO cube as often on the green button if he has 2 cubes. He does the same with the second CiFTO cube. Then he clicks on the OK button and gets the result of the mathematical task. Also, the CiFTO cubes changed its background color into green. By touching the red button with the CiFTO cube, you can give the cube away. If a user finds the same task twice, he gets the information that its solution is right, but he found it already. If a user don't segment every cube onto the CiFTO cubes, the color of CiFTO cube's background will change into red, like you see here in the example. As a last function, the learner can push the little cubes to every display he wants by pressing them together. In the course mode, the difficulty will be increased by increasing the number to segment, and the number of CiFTO cubes an amount has to be segmented. Also, some special tasks could be implemented. For example, segment an amount 6 so that the most cubes are on the third CiFTO cube. Here, a user don't see how many possibilities of segmentations are available. A learner can choose which number should get segmented and by pressing the plus button on how many CiFTO cubes. In this mode, a teacher should work with the student and let him find some arguments why a number can be segmented or not. That was my final presentation for the course Design of Edu-Tech at Wintersemester 2013-2014. Thanks for watching.